Hello, everybody. How's it going?
Hey, hey, what is up?
It's another glorious Thursday here in North Carolina. So I took a little trip this week. I'm going to be over at B-Sides RDU tomorrow. It should be a good time. We'll see how it goes. So we'll give everybody a second to trickle in, and we will get started. Today we're obviously talking about something pretty interesting and that's catchy. All of these threat actor names and things here recently are always grabbing people's attention. So this is one we want to highlight. It's gotten a lot of noise lately, and we built out something pretty cool to kind of test against it. So if I was to describe a group of individuals, let's say, as, young, like late teens, mid 20s, that kind of range, they're very innovative, very hungry, very tech savvy. What would you think I'm talking about?
Is
It's
it
probably
a
something like a
startup?
startup, right? Yeah. It sounds exactly like a Silicon Valley startup, things like that. But no, that actually is a really apt description of the group scattered spider, who's what we're here to talk about today. They're kind of really had an evolution over 2025 going into this year, where they went from being just kind of rather unsophisticated, doing things like SIM swapping attacks, so all of a sudden, they're very coordinated in their operations. They're doing very specific things post-compromise once they get into an environment. They're even going so far as dwelling in those environments for a while, impersonating users, even at one point going so far as to like join the incident response, like Teams calls and things like that, to see how these organizations are looking for them so they can try and persist longer. It's pretty wild how all of a sudden they changed. So we're highlighting them a little bit today, and we'll step through some of the key behaviors we've seen from them from a post-compromise perspective. Now let me share my screen here real quick. We created a threat here. I want to say this was at the beginning of August for Scythe customers to utilize, and all in all, it is kind of interesting. What we've got going on here, obviously, like any threat, you always say we give you a nice fancy diamond model, right? That describes what's going on. But we started off with the normal system information enumeration. They do the same things over and over again. You're going to see them do things like, who am I, checking ARP, IP config, system info. Nothing like super crazy, right? The kind of difference in this stuff and what they've been doing here too is they'll do a couple of different like task lists or other enumeration steps where they're actually looking for your defensive tooling and any other kind of like security software you have in place. So we emulated that within here as well. They're doing things like checking for like, is Defender running, is Splunk there, Sysmon, things like that. Once they've got their kind of enumeration out of the way, they're diving into obviously persistence, right? They want to find a way to get in, and stay as long as possible before they kind of hit you with some ransomware and get out of Dodge. So Scattered Spider's been known to use, open source tools living off the land and anything kind of freemium, they're about it. Some of the notable examples had showed them utilizing AnyDesk as their tool of choice. So we emulated that in this environment by setting it up as an unattended access. So we bring in the portable version, we go in and we set up a registry key, we insert creds for it so that we can kind of use it as getting our own callback. There's no authentication or steps required from a GUI perspective or the user to interact with it. And that's how we're kind of emulating that whole RMM piece here. But they also do like their persistence through, the registry keys, through scheduled tasks. All of that is happening in here as well. So they're kind of making sure they're really embedded in the systems they're operating on. Next thing is they're doing their whole little cred uh, enumeration and exfil piece. They're looking to elevate, right? The higher priv they can get, the better access they have, the more they can move, the more they can do. So they're doing things like digging through your browser creds. They're going to run like DC sync to actually like dump creds, learn about the domain, what's going on, and elevate as fast as possible. Once they've done all of that elevation and enumeration, is when they get into their lateral movement and then ransomware. They've been known to use PSExec in the past, so we showed an interesting way of doing that within our threat, basically just setting some variables in the campaign real quick, and then just running it through upshell, just using an invoke command. Nothing too crazy. Then lastly, the ransomware piece, right? One thing that's notable about Scattered Spider is they have been known to use several different variants of ransomware. Obviously, here in the article, you can see like Dragon Force, Quill, and Akira. They've all been seen to come from the same group. So instead of trying to emulate any one particular strain of ransomware, we went a little bit more of a generic route with this threat. And we're utilizing just the direct Windows Crypt API and some of our other modules to emulate this overall behavior. So instead of it being a little more like hyper specific, can you detect a specific ransomware that's more of a can you detect the behaviors that happen before and after ransomware as a whole? And that's what we've kind of got going on here for you guys. I'll do a quick run through so you can kind of see some of these steps in action. I want to highlight some of the key notable ones. Obviously, as soon as they start, they're trying to get lay of the land. Who am I? Where am I at? What's going on the endpoint? Normal IP configuration stuff. And then ARP, they're trying to see, okay, what's around me? What can I reach? Is there anything local that I should know of and try to laterally move to here soon? That's what we've got going on. From there, we're doing a quick simple task list using that find string, looking for anything like sysmon, winlogdeek, Splunk. For those of you that happen to be utilizing this threat within your own environment, you can easily change these up to match whatever tools you're utilizing, or maybe you want to see if it can detect something different. So instead of saying like Splunk, you could say Elastic, or pick your SIEM and EDR and whatever else are your monitoring tools that you have in place, and just replace these values here. From there, we can see them doing that whole security product discovery in our output here from our lab that we had set up. It's just running, basic Defender. There's nothing crazy at the moment. And then we get into actually pulling in the RMM tools and all of the other stuff necessary for this threat to run. We see that happens real fast. Don't mind the actual error here. That's basically just telling us the file already existed on disk. We reran this just to make sure everything worked. From there, go ahead and setting up that scheduled task. We're doing a start job. We're running the actual system update executable. And then we're going to use get process, find out what's the name, ID, and path for that AnyDesk setup that we have in place. It pulls that information back for us, and then we use that information within our next following steps to actually set it up as the unattended access piece. Once we do that, we put in the registry key changes and we run, create our task itself whenever we want it to run, tells us it's created. Here's the information just because we're validating it again. The typical thread's not going to come back and do this, but this is good from a visualization and validation perspective, so we like to include it at times. We see our things happening, and then when we get up here, let me scroll a bit, we can see we restarted the service, and then we started doing a lot of the actual enumeration piece. So from here, we can see it copying out all the different databases and places where browser credentials and other things are typically stored. So we're starting to get into like the actual fun steps and behaviors here. Let's slide on up here a little bit, get to some of the more interesting pieces. I want to show so here we can see the actual behavior of this step where we're echoing in the credential for our unattended access. And then we can see the actual request here. I believe this one was for, where's it at? There we go. So the script we were running to do our AD enumeration. It's a little long, so I had it collapse there. But that's what our typical output looks like. It's nothing crazy, but all of these behaviors are still running in the background. You're seeing them happen from basic, command prompt PowerShell perspectives to a little more stealthy using unmanaged PowerShell and running scripts. So you're getting a really good variance and look at all the different behaviors and way those behaviors can be executed, which is really interesting in and of itself. Then lastly, let me get up here to the top. We rounded this out with our actual ransomware. We can see from this point, we just made a bunch of random fake files out of a specific size on the endpoint for you in your environment. If you were a Scythe user, you could switch this out. Instead of it being us generating the files, you target maybe specific directories, drives, things like that. Then we use that crypt API or crypt module within Scythe to call it to go ahead and set those passwords on all of the files, change the extensions, and encrypt them. From there, we do a real quick pull down of the ransom note, we drop it in the place we want it to be and open it. And then we compress all of those files that we had and exfil them from the environment before we're done. So all in all, that's what we kind of have here built for you guys. This was a really interesting way for us to show off the different behaviors that this group is known for. Tyler, you want to jump into detections?
Yeah, for sure. Just share my screen.
So there's a lot going on in this one, so I tried to be a little fast at times because I know that we're already like halfway through our supposed
Yep.
death time, right?
No, halfway will be perfect. We don't have too many detections to go through, but just a couple of them on there. So you saw when Trey was talking about what Scattered Spider was doing, that it does try to perform some kind of LSAS dump in here. So in our emulation, you see that they utilize run DLL 32 to then call com svcs .dll, which will do a mini dump on the endpoint. So doing some living off the land to try to dump this LSAS to dump your LSAS memory to try to extract some passwords later on. So in this detection, we are looking for some keywords such as the mini dump, the lsas.dmp, as well as looking for that being spawned from the image of run DLL 32. Typically you don't see run DLL 32 being launched from processes outside of really like those system files we always talk about. So another good detection for this would just be looking for images such as run DLL 32 or PowerShell or CMD, like we always say, being spawned from parent images outside of those standard directories, right? So outside of program files, outside of system 32, things like that. That would also bring a lot of this to light. Next up is a PS exec. We love to utilize PS exec PowerShell execution in really a lot of our threats, really all of our threats. We see it's super common for adversaries to run it. It's signed by Microsoft, so it's a great tool for adversaries to use. So you need to really kind of monitor the commands that are being ran through PS exec. If you allow it in your environment, if you don't allow PS exec in your environment, then you should really be monitoring this for if you get any hits on this, then you know that probably something is bad, right? You at least have what is it, the PUA potentially unwanted applications or something like that, or it could be something more malicious, more adversarial focused. So in this, we're just looking for the image of PS exec and then just running all of the, and then just polling all of the values of the command line arguments. You could also update this to not only look for image, but also look for who it was digitally signed by, look for the product name, different things like that. It's very easy to change the image name, but doing some of the other like products and things like that could be a little more not difficult, but a little more time consuming. And adversaries have day jobs too, right? So they don't always have time to go through and change every little bit. So the wider you spread out your detections for this, the more likely that you'll be able to identify them. And then next up, some of that initial recon. So I know Trey had shown not only initial recon, but some of the defensive evasion techniques as well. Excuse me, looking for Sysmon, WinLogBeat, and Splunk, looking for some common security tooling or common logging that you would expect to see on an endpoint. For this is all just this is keyword based off of the command line value. So in here in this detection, we have if the command line is this long list of all these different security tools, right? We have CrowdStrike in there, Sysmon's in there, WinLogBeat, Splunk, Defender, whatever flavor of antivirus. We have a lot of those in there, but this is all just keyword-based detections, just trying to find some of these product names. Ideally, you would probably look for this. So like we saw in there that they do that initial recon kind of as a precursor to defense evasion. So I would say if you see a command like this that's running, that's triggering on looking for EDRs or antiviruses, different security tooling or agents on the endpoint, I would then probably pivot over to looking at services being turned off or processes being terminated that match these command line values that they're looking for. So I would look and see, if you do run Splunk or WinLongBeat or whatever it is in your environment, the next step after this would probably be to pivot and look if that service is still running, if it was terminated by someone, and then if those timelines aligned with each other. That's a good tip off of adversarial behavior, right? Uh, then into RMM persistence, like Trey was saying, AnyDesk, TeamViewer, there's a bunch of other ones, but those are also super hot for adversaries to use. They love to utilize them. A lot of people run them already natively in their environment, so it's not quite living off the land, but it could be, right? If you already have it in your environment, they just piggyback off of that. The one point I did want to pick up on here is you see the image does say system update, but the product is AnyDesk. That was what I was alluding to a little while ago, and that changing the image is really just as simple as changing what the name of that process is, right? Just right click, rename, change it to whatever you want. In our instance, we downloaded it and called it system update once it was downloaded, so we didn't rename it. But it's really that simple to change what the image name is to utilize or to change the product, or any of that EXIF data in there. You have to utilize some additional tooling. It's not super complicated, but it is time consuming, where an adversary might not do that. So if you were just looking in this instance, if you were just looking for the image of AnyDesk, you wouldn't see this, right? But by looking at the product of AnyDesk, it's just one example to identify it. You can also, in some of our detections for this, we don't have it in this one, but in some of our other detections for identifying RMM tooling, specifically AnyDesk, once these tools stand up, they start their own, essentially their own out-of-band network that will allow the AnyDesk applications to talk to other AnyDesk applications. And all of them are pretty much like this, right? TeamViewer does the same thing. So another great detection is to look for that that network being stood up, or these specific DNS names um, that they utilize in their network, because that's much more difficult to change, right? That's changing actually how the application works. That's not something that we typically see being modified. If somebody's going to do that, they're probably just going to make their own C2, right? So if they utilize a product like AnyDesk or TeamViewer, things like that, that's another great detection to look through. That's a little, that again is more difficult to change, right? Always focusing on those state-based detections and less on just the keyword detections, which actually really fits very apropos for our next detection that we have. So looking for scheduled task creation. Excuse me. So in here we see that we're looking inside of the tasks directory. The reason that we're doing that is because no matter how you create a scheduled task, for it to be written to disk, it has to be written inside the tasks directory. Either the Windows tasks, I think there's a System 32 tasks. I think there's like a temporary user profile one as well. There's like 3 or 4 different tasks locations where scheduled tasks are written to. So this is a great state-based detection because we're not concerned with how it got there. We're just concerned that a new scheduled task exists. So we can see they have these sa.dat scheduled tasks in there. That's something that happens when the machine turns on. This instance of what we're hunting on, these machines are in our core stack lab environment. So when we turned it on, that's why it created those sa.dat files. Could still be something for you to look into. You could just rename your campaign, or excuse me, you could rename your image or your scheduled task to fit that sa.dat, but it's pretty standard that you would see something like that. The one that we're more concerned with is the system maintenance down there at the bottom. That's something that was caused from our campaign. So just monitoring those task directories, or even if you don't have the names of them, you could even just change the visualization to be a number. I don't remember what the visualization is called, but you could have it be a number on your stats count, and then in the bottom right corner, it'll show a up or down arrow with a number next to it to what the change is every day or every hour, whatever you have it set up to. So even having something like that, just to be like, oh, we have 2 new scheduled tasks, like we should probably investigate that, is something that you could also look at. Another one is your scheduled tasks should be written by SVC host. SVC host controls the services and scheduled tasks and things like that. So SVC host is the image that should be creating these files. But what you could do, or what an adversary could also do, is copy a file directly to that directory. Now it's a registered scheduled task. But if they were to do it that way, where they just copy it over instead of using a traditional, PowerShell command or something like that to create the scheduled task, if they just copy it over there, that image is going to be different, right? The image is going to be PowerShell. That image is going to be implant, evil.exe, whatever it is. So also monitoring for that suspicious parent image is also a good way to kind of have it rise up to the top as far as malicious or anomalous. I don't like to say that things are malicious right out of the bat because computers do weird stuff, right? Um, Next up is some of the ransomware behaviors. So we didn't focus on this one of showing like multiple files being created at one time in a certain directory. We've shown that in some of the other TT lives. This again is a keyword based detection that we have. So it's looking at the values of the target file name, or excuse me, it's looking at what the target file name is and then listing out those values here. So it's looking for really keywords. Like I said, it's looking for ransom, how to decrypt, things like that, typical file names you would see with ransomware. Again, we have some other detections where it's looking for the common file extensions. Like in this one, I believe it was $XB, dot Medusa, dot Lockbit, different things like that is also a detection you could put in place. But those won't trigger, just like this one, won't trigger until after those events happen. So it won't really enable you to catch it in real time, where maybe file creations, like 100 file creations in a directory in a few seconds, maybe would trigger it and give you a little bit of time to stop it. But once ransomware starts, it can be very difficult to kind of catch it in the middle of it when it only takes a few seconds. Yeah, here again, just looking at kind of those keyword based detections based on the file name. And then I believe this is the last one, that AD credential extraction. So this here, see software update.exe is our renamed, it's one of our renamed executables that's looking to pull out browser extraction stuff. So this is going into Chrome and Edge to pull out different information from those browsers, like passwords, history, cached, bookmarks, things like that. Whatever, just think of what you would utilize your browser for, right? Adversaries want that. Even something as maybe innocuous seeming as your history. If they get your Chrome history or Edge history, something like that, they can see the internal sites that you go to. And then obviously, if you have any passwords stored in there or anything like that, they could pull those down, try to crack those offline. And then next up is the AD Recon, which was ran. This was ran via upshell, so the command line arguments could be a little more difficult to identify because the logging is different with upshell. It's not that standard, 4688 process creation ID. So instead of focusing on the keyword detections for the commands that were being ran, we instead did some keyword detections on the standard files and file names that are created from AD Recon running. So like these domain admins, domain trust, enterprise admins, and then they all end in a .txt, excuse me, as well as the adrecon.zip file itself. So again, kind of focusing, or I shouldn't say focusing, looking at things that are not impossible to change, but more difficult. It takes a little more time for an adversary to change it. We saw in a lot of the CTI for Scattered Spider and for a lot of adversaries, actually, they don't even really bother changing the default names because if they can get it to execute, then a lot of people aren't looking for it any other way. A lot of the time it's we see that people are reliant more on just the EDR catching kind of what's happening. AD Recon is a pretty standard tool that should be caught. But by focusing again on some of these defaults, some of the things that you expect to see, it could maybe give you a leg up if it's not being seen by your EDR or the alerts aren't coming in the way that you think they are. But with that, I know that I went a little bit over, but these are the detections that we have for Scattered Spider. Yeah, back on over to you, Trey. Switch our camera so we're back on.
Oh, got it.
Booyah.
Oh, cool. So yeah, that's kind of what we got built out for you guys. We just wanted to give you a quick look into the scattered spider threat we've had, some of the different behaviors that they've been known to utilize, and wanted to show it off. If you guys have any questions, concerns, let us know in the chat, on socials, anywhere else. We'd love to hear your guys' insights on this threat actor and what's going on. Last two blurbs. If you would ever like to come on to Threat Thursday Live, maybe talk about something cool, maybe some detections, a threat actor, a case you've had to work, anything like that, just shoot us a message and let us know. We'd love to have you on. And for those of you in the Raleigh Durham area, if you're going to be at B-Sides tomorrow, come find me. I'd love to chat.
Sure. For those of you in the St. Louis area, I live here, so would love to come and chat too. I just felt like I should say something. Uh,
Yeah,
but for sure,
perfect.
yeah, check out Trey's going to give a great talk. Thanks everybody for hopping on, and hope to see you next week.
Until then.
Here, buddy.